The next speaker is from Aalto University, Professor Heikki Hämmäinen at the Department of Communication and Networking. And he will be speaking about LuxTurrim 5G innovation project. Heikki, the floor is yours.
Okay, thank you. Thank you, Andre. Let me try to share the screen. Let's see. Okay, here we go. So, yeah, my name is Heikki Hämmäinen. I'm professor in the Department of Networking, Communications and Networking. And my research group is involved in this LuxTurrim 5G project or umbrella. It's actually more than one project. And here I will present some work of this LuxTurrim project. And the project is led, by the way, by Nokia. It's a big project with many partners. I will tell more about that soon. And the project contains many tracks, but I have picked up something that relates to autonomous systems. And let's see how we get ahead here. So here you can see the big picture. Why to have this kind of smart city project like LuxTurrim 5G. Lots of the challenges thinking about sustainability are, of course, in cities. Cities, as we well know, and for instance, United Nations has published the sustainability objectives, which closely touch the items that this project also is addressing. So the general driver to increase sustainable automation in cities is the target of the project. And let's move ahead. So here we can see the focused pilot environment of the project. So the project is focused on the Kera area. So in Espoo we have a pilot area, which is actually consisting of 5G light poles. So light poles, street light poles, which have been equipped with 4G, 5G base stations and many sensors. More about that soon. So intelligent poles, and the project is has two different tracks on the high level. One is related to the light poles and the connectivity platform, sensors and IoT on close to the light poles, and the other part is a secured local data platform, and I will briefly touch both of these aspects. So you can actually, if you go to the close to Nokia headquarters in Nokia campus, you can see some of these light poles, and also if you check the connection between the Kera railway station and Nokia headquarters, you can see the light poles. And there is some testing ongoing now, and there will be also a bit more serious piloting of robot buses, autonomous buses as well, later on next year. And here you can see the data platform and services part of the track of the project context, and it is called neutral host pilot, and I will come back to the logic of the name, the neutral host, here soon. But first about partners. So you can see a lot of companies, Nokia as the driving force, and Nokia has put quite an effort both on the 5G light poles and the base stations, the connectivity platform, as well as to the data platform and some of the piloted services as well. And you can see here mainly the partners of the kind of higher layer related to data platform, but then you can see additional partners here on the lower right corner related to to the IoT and kind of sensor part. You can see Rumble Tools, which is a company focusing on drones, and you can see different other companies related to some other use cases and sensors in the smart city context. Here you can see an example of the 5G smart light pole. There are different versions of this because depending on the location, for instance, the height of the pole is varying and also style. So the concept is also evolving now, kind of from version to version, which makes it a little bit more difficult to kind of define what exactly is this smart pole. But you can see that it's essentially divided in 3 areas. There are certain sensors, for instance, and devices that work best on the top of the pole, like base stations and the drone docking station, weather sensors, and GPS positioning devices, and so on. And there are some other devices that work best at the bottom of the pole, like the chargers, electric car and bicycle chargers, and also the kind of electromechanics, including a battery as a kind of backup battery, and some of the electronics is best located there. And some sensors can be located more flexibly also in the middle of the pole. But there is lots of design challenges. From Aalto, we have actually design expert, artist designs involved, and also the design factories involved, and some material experts, because the pole materials need to be specific because of the long life cycle, and because of the electromagnetic radiation requirements of different sensors and parts of the pole, and durability and so on. This, of course, the weight of the pole also increases because all of this equipment connected to it. Then thinking about the smart city challenge. So one challenge are the individual kind of focused services and sensors, and the technical challenges there. But the bigger challenge is the integration, because when we think about the autonomous aspects and the challenge of increasing the level of automation in a city environment, we come back to the questions of centralized and local data and real-time versus non-real-time control. And all of this raises the question of situational awareness, which is a centerpiece. The situational awareness and digital twins in this particular area. And the challenge is that the situational awareness is very well handled by human users, and the earlier services and communication solutions based on smartphones, they take care that the human brain and humans can handle the situational awareness extended by digital information quite well, but the devices, in case that they make decisions based on automatic solutions on software and data. The challenge is to share the information among different parties in an optimal way, which allows the higher level of automation and more intelligent decision making in each different device. Here you can see the cars and light poles and sensors there, which are not only sensors, there are actuators to create sounds and to warn people about things, and and to have there are also some information screens to guide people and so on, and it would be very expensive to have totally isolated construction of situational awareness for all different devices in this environment, but it's also very challenging to create the sharing mechanisms, especially when going towards more real-time sharing of information. But this is kind of a high-level view. Now this is a collection of use cases from the project, and I'm not intending to go through all of this. I have marked with red those that have more to do with autonomous systems. That you can see examples here of smart transportation, the autonomous bus, remote driving, connected traffic, and then on smart logistics, the last mile delivery, drones, using drones or cars, which have this big significant business potential and opportunity to increase the level of automation. And all of these are one way or the other tackled in the project by different parties. I can maybe dive a bit deeper into this traffic use cases. Here you can see one snapshot of one of our studies. You have use cases on the left horizontally here, and various parameters vertically to compare on a high level, on qualitative level, these different use cases. And the purpose of this analysis was to look for the 5G use cases attractive to 5G, for instance, based on the real-time need, the low latency, for instance. And you can see that quite many of these use cases are benefiting from the real-time capabilities of 5G. I would like to bring up one use case which was already touched in Kimmo's presentation, just briefly. So we have this let's say the robot bus use case, but then we have also remote driving, and they link together quite closely, because you can see the remote driving here, the second but last row, remote driving. And from a techno-economic perspective or from business case perspective, it's challenging because it's very difficult to create the autonomous capability for a bus, even in a well-defined route and well-defined environment. There are still many steps to be done, but to make it business feasible a bit earlier, it's necessary to combine the remote driving capability there, because the autonomous buses will end up statistically into different kinds of troubles which require intervention by a human remote driver, and then we need this remote driver use case to work well. But the problem is that this remote driving is quite expensive also, and it only makes sense if a remote driver is able to, from a remote monitoring center to handle multiple buses at the same time, or not maybe exactly at the same time, but kind of being responsible of a fleet at the same time. If there is one person needed per bus remotely, then the cost is not going down. It's kind of the same cost of having a human driver all the time there, and this creates motivation to improve the remote driving capability. But eventually the target is to not use remote driving because of the high cost of human operated remote driving. So the business case is improving the less there is human driving. And so the business case is in a way complicated because the target is to get rid of the whole business case. Okay, let's go further. So we have our role, and my research group in this LuxTurrim project, we have analyzed both kind of techno-economic structural problems, which means that combining the technical architectures with market architectures or value networks. And here you can see one example of a breakdown of or structuring the smart city business. You can see the vertical businesses related to certain use cases and services, and then you can see the data platform, connectivity platform, and the big infrastructure business, including all related electronics and digging and deploy capital and operational costs related to that. Then we can see another example of structuring the problem. Here we can see a value network configuration. I don't dive deeper into the actual notation here, but you can see that this example here, it's using the vehicle just as a minor example in this case, but the main message here is that there is a neutral host or neutral connectivity operator, and MNOs are using this neutral connectivity operator, which means that there is kind of a single infrastructure for 5G small cells in the city, and different mobile operators cooperating in using that platform, using the same platform but competing on the level of services. And there are other options for this, for structuring the market, and you can see here that the joint MNO driven platform, which means that this neutral connectivity operator would not be a third party but would be kind of owned and operated jointly by the nationwide mobile network operators. Like in Finland, it would be Elisa, Telia, and DNA. Or it could be actually also a cloud provider using kind of local licensing mechanisms and combining the data platform and connectivity platform and operating as a whole. There are these kind of efforts happening somewhere in the world, experiments and piloting and so on. But it's so far unclear which of these alternatives will actually materialize. So let's move ahead. So this is a different view to the smart city environment. This is about one of our studies where where we are forecasting the city mobile data traffic, and in this case we have done detailed analysis for downtown Helsinki for certain postal codes, and by identifying the kind of time series data from a couple of years, and then extending that data, including devices and traffic, and then looking at the specific environment and estimating the device diffusion and traffic diffusion, and the results so far are showing that this machine-generated traffic or automatic traffic is increasing gradually, but by 2030 it will be still less than 20%. Smartphones are dominating, and we have done some sensitivity analysis, especially related to policy and regulation. And couple of interesting observations so far. So these video cameras, they are quite sensitive to policy and regulation questions, especially because of privacy issues. So forecasting that component of traffic is a bit more tricky or has bigger error margins. On the other hand, the car and bus, the traffic related data traffic, so transport and car bus traffic related data traffic is less sensitive. And one interesting observation also is the question that how fast the 5G small cells are potentially needed, which means we have big investments going to smaller cells and building new base station sites. That in this case, in Helsinki downtown, it would be like 2025, where the traffic growth is pushing towards big investments into small cells. But then specific services, because of the service requirements, can do this, can motivate actors to do this earlier. Okay, so at this point, thanks to the audience